My name is Jyoti Verma, and the title for my poster is Structural Insight into Differential Recognition of an Allosteric Inhibitor by Insulin Receptor and IGF-1R kinase. Allosteric inhibition in kinases, which aims at targeting the non-ATP binding regions, is a promising approach to achieve selectivity in kinase drug discovery. The insulin like growth factor 1 receptor kinase and insulin receptor kinase are homologous protein members of the receptor tyrosine kinase family. They are involved in multiple cell signaling pathways and hence are important therapeutic target. In an experimental study, an indole butylamine derivative has been discovered as an allosteric inhibitor of IGF-1R kinase. The cellular assays in the same study highlight the selectivity of the inhibitor towards IGF-1R kinase with IC50 value of 0.5 micromolar over the homolog IR kinase with an IC50 value of 6.9 micromolar. The study also reports an X-ray crystal structure of the IGF-1R kinase bound to the allosteric inhibitor. However, there is no structural information of the binding of this allosteric inhibitor with IR kinase. Also, interestingly, these proteins share 75% sequence identity in their kinase domain and they are structurally homologous. What intrigued us more is that the binding pocket residues where the allosteric inhibitor binds in the IGF-1R kinase is identical as in the insulin receptor kinase. Hence, we wanted to understand the molecular factors responsible for the selectivity of the inhibitor towards IGF-1R kinase over IR kinase. And we also want to provide a structural model for the allosteric inhibitor with the IR kinase. In our study, we first performed structural comparison followed by molecular docking of the allosteric inhibitor to IR kinase using glide module of the Schrödinger to get an initial binding conformation. Then we performed all atom molecular dynamics simulation with all the complex and followed by binding free energy calculations. Structural superimposition of IR EPO structure with IGF-1R kinase inhibitor bound and unbound form revealed that the two methionine residues of the IR kinase in the binding pocket have altered conformation such that they will block the binding or may cause steric overlap for the inhibitor in the IR kinase pocket. We also found that there is a potential role of the DFG motif conformation for the inhibitor binding in the IGF-1R kinase. The molecular docking results also revealed a distinct conformation of the inhibitor in the IR kinase pocket. We further performed the molecular dynamic simulation of these complexes to understand the conformational dynamics of the inhibitor in both the binding pockets. From the simulation trajectories, we performed PCA analysis to get the dominant conformations of the complexes. The dominant clusters of inhibitor conformations shows relatively stable conformations of the inhibitor in the IR kinase pocket in the IGF-1R kinase pocket as compared to the IR kinase, revealing an overall stability of the inhibitor in the IGF-1R kinase pocket. We then also compared the conformational dynamics of the protein structures, the dynamics of the methionine side chain residues and the DFG motif in the inhibitor bound form, and as well as the EPO conformations confirmed the role of conformational selection and induced fit in the binding of allosteric inhibitor in IGF-1R kinase. The findings from the conformational dynamics suggest that the conformation of the residues methionine 1054 and methionine 1079, coupled with the outward movement of the alpha C helix and stable DFG motif conformation, favors the selectivity of this allosteric inhibitor towards IGF-1R kinase. Further, the binding free energy calculations and residue interactions that reveal that the selectivity attained is as a result of the difference in the electrostatic interaction energy, which was more negative for the IGF-1R kinase, and the formation of a unique hydrogen bond which was stable in the IGF-1R kinase pocket. The hydrogen bond between the indole ring and valine 1063 of IGF-1R kinase is absent with the corresponding valine 1060 residue in IR kinase, hence providing directionality and specificity to the allosteric inhibitor, thereby making it selective for IGF-1R kinase over IR kinase. Overall, the findings from our study enable a better understanding of the IGF-1R kinase and IR kinase allosteric inhibitor binding mechanism and may potentially aid in developing selective kinase inhibitor. Thank you.